So what can lead to a different species? A key event could be when that population is cut off from its parent population. So let's say that there's a event where that new population is taken away from that original parent population. For instance, let's say that there's a geographic barrier, let's say a mountain range, for instance, or an earthquake leading to a physical isolation. That is called an allopatric speciation event. So in allopatric speciation, we have a block to gene flow because of a geographic barrier that physically isolates that population. Here in this example, I have two different species of squirrels. They're very much two different species. They are quite similar because originally they were the same species. Over time, here I can see rims of the Grand Canyon separating the two. And over time, enough adaptations have allowed for their squirrels to now become different species. And so this is called allopatric speciation due to that geographic barrier that physically isolates the two. So this is going to be, again, evolution, as we discussed, events, really beautiful adaptations, helping to promote these species to adapt in their environment. Last thing I just want to point out, so if I actually take this cute little guy right here and mix him with this other cute little guy right here, two different species, that doesn't mean that they'll eventually fuse into the same species again. They're now two species, and they will keep being two different species, even if you take that geographic barrier away at this point. Sympatric speciation is the other type that I want to discuss. Sympatric speciation has to do with new species arising within the same geographic area. So it's in the same area. There's no physical barrier. Here on the right side, I'm showing you that a new species of tree has formed by these light-colored trees here in the middle versus these dark-colored trees. There's no physical barrier that's separating them from the original population. It just so happened that these organisms, for many different reasons, became its own. Why would this happen? There are many examples that I won't go into too much detail, but maybe this was an accident during cell division. I taught you guys cell division, and there are many different steps along that process. Things can go wrong during that process. Hence, new species can form. Mutations can lead to this. Habitat complexity, maybe, okay, there wasn't a mountain range, there wasn't a geographic barrier there, but maybe the habitat itself was already complex. And so new species can adapt due to that complex environment already. Sexual selection is an example of this. So this would be kind of a more behavioral type, maybe preferences of one organism led to that new species. And if there are enough individuals with that sexual preference versus others, you can get a new species resulting over time. We're talking about those prezygotic barriers. Postzygotic barriers can also contribute to this as well, leading to new species. This is sympatric speciation. Okay, Paul, how can I ask you this? What type of speciation is being shown? It looks like I have these cute little guys, these cute little dinosaurs, little T-Rex, small hands, big heads. Okay, I have this aqua dinosaur, I have this light green dinosaur, a number of them, and it looks like there's sexual selection event going on. It looks like there is a mating preference for these guys. Those aqua colors preferring each other, those light green colors preferring each other. And over time, it looks like I have new species being formed, shown by these dashed dots. So what could that be? Allopatric or sympatric speciation event? This is definitely sympatric speciation. Allopatric would be telling me that there's an actual geographic barrier, like let's say a mountain range there, between those guys, that rift of the Grand Canyon in the example I gave you. There's no geographic barrier. It looks like a prezygotic barrier. Behavioral isolation is being shown here. That's a sympatric speciation event.